Hello and welcome everyone. We are in day 7 of DSA Made Easy, and in this session we are going to be looking at all the previous 6 days of topics that we have learned so far as a revision of topics. So in the day 1 we had verified variables and data types. Variables and data types, where variables were some placeholder for values, right? And data types were primitive data types like int, float, bool, so on. We also had abstract data types where if we wanted to define custom data types like say a person having attributes of age, name, address, right? These were our learnings, and in the day 2 we came across abstract data types, data structures and abstract data types. We understood that data structures is a way of organizing and retrieving data. And ADTs, wherein stands for abstract data types. Like let's say if we had a custom data type which had operations on them, like for example stacks, trees, graphs, so on, which have operations on them like to push an element or to add a node or any of the operations on them. So then we call them abstract data types, which is like a complete package including the custom data type along with the operations that are performed with them, right? And next thing was in day 3 we came across algorithms and analysis. Algorithm is nothing but a series of steps that we take to perform a specific task. Perform task. And analysis is a way of measuring if work is getting done, if it works, and also the efficiency with time and space, time and memory, right? So this was our initial learning, and once we moved on to day 4 where we looked at rate of growth and types of analysis. So let's say different algorithms can be represented as functions. Let's say f of n is equals to 100 n square plus 300 n plus 700. So this is n square, and this is n, and this is constant, right? So we can say f of n is directly proportional to n square in the worst case complexity. And we also saw rate of growth for different functions of n, like let's say f of n and time. So something like this is n square, and a constant would be like this. No matter how much time changes, this always remains the same, and this is f of n, where it is directly proportional to n. Okay, so this was rate of growth, where different functions have different representation with respect to time. And in day 5, we in day 5 topic, we came across asymptotic Asym- analysis of big O, omega, and theta, right? So we can say big O is worst case, worst, average, and this would be the best case. So best case scenario, this might be constant only, and in average case, this might be uh, like let's say the n and the constant, and in this case it might be n square plus n and the constant, some a e and constant, right? So we always consider big O, right, the worst case part. And we also looked at Master's theorem, and recurrence. So recurrence is, let's say f of n needs to be computed for a factorial of n, then we do it like this: n minus 1 factorial, and so on, right? So, and here base cases would be, base case would be if n is equals to 0, f of n is equals to 1, and n is equals to 1, f of n is equals to 1. And for all the other cases, f of, let's say f of n is equals to 2, n is equals to 1 into f of 2, f of 1 into f of 0. This again will be 2 into 1 into 1. So this will be 2. N is equals to 3 will be f of n is equals to f of 3 into f of 2. f of 2 is 2, and this will be 3. So this will be 6. So it will go on, right? So that's how recurrences work. And for master theorem, we can derive a specific representation for recurrence. Like for example, we can say T of n is equals to a into n by b plus f of n. This is a recurrence part, and this function would be non-recurrence. And a is number of subproblems here. B is size of subproblem. Let's say we can also take an example of binary search, where we can say a is equals to 1 and b will be 2, and we can replace the values of a and b in the master theorem, and we get an equation. And similarly, in merge sort, we get a is equals to 2, b is equals to 2, and we get another master's theorem equation, right? So this is all that we had so far. In the next set of learnings, we are going to look at recursion and backtracking as part of chapter 2, right? Thank you.